So hi everybody, I'm Stefano Zacchiaroli. I'm going to talk about how to share dependency resolution among different package managers and possibly even among different distributions. So the work is a representation of our ongoing work with Ralph Tynan and more generally with the team of the Mancusi project. So I'm personally both a Debian developer and a member of that project, and this presentation will not be specifically on the project as a whole, but very briefly, the Mancusi project is taking care of trying to improve various aspects of package management in various package-based distributions. And in particular, today I'm talking about the work we are doing on the side of dependency resolution. So this is a brief overview of what we're going to talk about. So first of all, some consideration of dependency solving in general, why it is important in Linux distributions. And then the main part of the talk, we describe a format called CUDF, which is used to represent dependency solving problems in a way which is independent of the specific package manager you're using. And finally, we will discuss a bit the current state of the format and where it has been deployed and where it is going to be used in the very near future. So just to remind a bit what we're doing here, we are all people from distributions. And our main role is actually being an intermediary between upstream, which writes software, but maybe don't care that much about how to give the software to their users, and the final users. So what we do, basically, we make easy for users to deploy software, to get it, to install it, and to have some kind of coherency in the set of software they've installed on their machine. And the key idea, of course, is the notion of package. So we identify each single component which can be installed or removed or upgraded as a sole component, and we call it a package. And of course, the main application a distribution offers to its users is a package manager. So it is no wonder that we had this kind of always going on battle between Debian or RPM kind of packages, because each distribution actually wants to have a very good package manager to offer better features than other distributions to their users. So what is the role of package managers then? Any idea of how to get rid of this one? As you guessed, this is not my laptop. Wonderful, thanks. So the main role of a package manager in whatever distribution is then to make easy to do software upgrades. And I will use software upgrades in a generic sense. So actually, whenever you change something in the set of packages installed in your machine, like install a new package, or remove an installed package, or upgrade a package to a newer version, or even downgrade, whatever, I will use the term software upgrade. So it is not specifically meant to go to a fresher version. So we want to make really easy and flexible this kind of software upgrades. And these are the main feature which a package manager offers usually. So the step 0 is avoiding user to download manually tarballs from the internet. So we don't want them to do wget, to do configure, to install all the needed library to compile the software, and so on. And basically, this is the first step which is done by a package manager, which also additionally offers the so-called trust path. So we offer GPG signed packages so that the user is sure that packages have been checked by someone he trusts, usually the distribution maintainer. Then the second feature offered by package managers is what I call low-level deployment. So that's the level of DPKG or RPM or whatever. So at that level, the package manager install all the files on the file system, and then offer a lot of very fancy features like triggers or transactional upgrades, or the management of configuration file, or the management of different kind of utility which implement the same API, and all this kind of stuff. And finally, and it is the point that I will more concern this talk, is dependency solving. So we want a user that wants to install OpenOffice or whatever big application to just say to the package manager that he wants to install that application, and the application will take care of recursively get all the needed dependencies to install that application. And similarly, we don't want the user to install two applications which are in conflict, meaning that they cannot work together. We want this to be automatically shielded from the user and spotted by the package manager. And finally, we want, for instance, when we release new big releases of a distribution to compute upgrade path. So like if you're using Debian or if you're using a Red Hat, when it changes from version 7 to version 8, you want to, your package manager to compute how to go from one release to the other, possibly minimizing the trouble you're going to encounter in the upgrade. So the main question is dependency solving as good as we want? So my personal answer and the answer of several users we have discussed with is no, it is not yet as good as we want, for various reasons. These are the main reasons why we think that dependency solving can be improved. The first reason is that currently most of the package manager are incomplete in their ability to solve dependencies. There are some exceptions, like OpenSUSE zip framework is a really complete dependency solver, but in most cases it is not. So for instance, I'm a Debian developer, so I have an example here using apt, but other package managers have similar issues. So basically you have like a package, version 2, which depends on a version 1 of a different package, and you have the same thing in the other direction. So a package B version 2, which depends on version 1 of package A. If you try to install both of the packages with apt, this will fail, because you will try to install together the most recent version of both packages, and it's not possible. Okay? But it is not true that the user request cannot be satisfied, because the user request simply asks to install A and B together, and there are at least 2 possible configurations in which you can install both packages together. So you can install version 2 of A with version 1 of B, or vice versa. Okay? So this is a very simple example where a package manager most of us, at least for the Debian side of the world, use, which cannot satisfy a very simple request of the user. Okay? This is a peculiar example, and there are tons of this kind of example in the most common package managers out there. A second reason why dependency solving can be improved in state-of-the-art package managers is like the expressivity we want from them. So usually we have a very limited language of install, upgrade, remove of this and that packages, and maybe some package managers have some more fancy features like the pinning in apt, but we are not yet able to express this kind of requests, which are called policies in some new package managers. So for instance, I want to state a policy that every time I do an upgrade on my system, I want to minimize the installed size on disk. For instance, because you have an embedded device. So among all the possible ways you have to satisfy user requests, you want to choose the one which minimizes how many space on disk is used. Okay? Similarly, you might want to minimize download size. There are countries in the world where the network connection is not as good as it is in most part of the Europe. You have maybe a 28 kilobit per second modem, and there you really want to choose among a very bloated web server. You want to choose another web server because it minimizes the number of packages you need to download from the network. Or similarly, in a very big distribution with a lot of maintainers, maybe you don't trust all of them. So you want, for instance, to blacklist all the packages maintained by a specific guy you don't trust. So when you ask the package manager to install something, choose a way to satisfy my request where no package by that guy are installed ever. Okay? So this is just an example, a sampling of policies you might want to express in package manager, but that today you cannot express. Finally, and this is mostly like a software engineering problem, the dependency solving component of a package manager is not so easy to implement. So technically, from a complexity point of view, the problem of solving dependencies is really hard. It's a so-called NP-complete problem. So if you implement it in a naive way, you will end up either with non-complete solver, which no wonder is what most complete are today, or you might end up in a dependency solving process which loops. So on the Debian side of the world, I guess a lot of us have met like aptitude looping while trying to solve dependencies, at some point giving up, asking you, should I continue or should I stop here? So this is kind of a problem which everyone which want to implement dependency solving will face. And quite interestingly, people which are writing like new package managers, like in Debian we have this day apt2 or capt or this kind of new package manager. The people we are writing this kind of solver are actually interested in not writing at all dependency solving and like reusing an external dependency solving component made by someone else, or maybe by reusing the dependency solver of a different package manager already existing. So the idea we are advancing is like, let's do what we do best. So sharing efforts. So there are a lot of dependency solvers out there. Basically, all package managers have an implementation of their own. And the idea is to try to reuse them among different actors. So the first idea is to reuse them among within a single distribution. So for instance, again, I have an example from Debian. We have different solvers, like we have build the implementation of different utilities. We have sbuild, we have pbuilder, we have apt itself can try to solve some dependencies. And you don't know which one will be used to solve dependencies. So you don't know what the result will be, because there can be some solvers which are better than other. And if you don't know in advance which one will be used, you will end up with different results. Another, let's say, field a bit larger in which we can try to reuse solvers is across different distributions. So this is a challenge, and like to try to reuse solvers between RPM world and Debian world. And also the third point, it's quite interesting. So in the scientific community, there are people which have been doing this kind of dependency solving for a lot of time, and they have a lot of expertise, and they are actually interested in the kind of data which distribution can offer. There are people like in Logics, which have been doing competition in trying to solve dependency problem, and which have been doing that on kind of fake data, built in vitro, let's say, to respect some statistical properties. But they are really interesting. They are really interested in the data which can come like from Debian users, because we have huge problems, like 20,000 packages, and we can offer them the data where to test whether the algorithms or the techniques are good or not. So the end goal of all this, it is not to propose a new standard package format to be shared by all distributions, because that is not going to work. Every distribution has its own package format for good reasons, but the end goal is so to just find a specific solving technique or a specific solving paradigm or a language to express user preferences or a specific implementation. And once we found one which is good for most of us, we can try to either deploy it individually in each package manager, or to factorize it out in a separate library to be used like by all solvers out there. Okay, so this is the main goal we are trying to achieve. And to that end, we have standardized a format which is called CUDF for Common Upgradability Description Format, which is a format in which you describe what we call an upgrade scenario. So an upgrade scenario is basically a set of 3 different things. So the first one is a so-called package universe. So basically all the universe known to the package manager. That does not only contain the packages which are installed on your machine, but all the one known that the package manager is able to download from the internet, for instance. The second part of an upgrade scenario is the package status, which is the subset of all these packages which are actually installed on your machine. Okay, so which is the start situation. And the third part is the user request. So what the user has asked the package manager to do to satisfy his request. So what are the problems in trying to define this kind of information in a way which is independent from a specific package manager and from a specific distribution? So this is a sampling of the main challenges. So the first challenge is that version numbers are different in different distributions. So Debian has a really specific lexical convention on what a version number is. Mandriva has a different one, Red Hat has another one. And the rules are actually quite subtle. So that's why when I see on the net proposal where you just offer a common installation architecture for all distribution, I get a bit skeptical, because this first problem, which is very simple, is quite tedious in the reality. Then we have the differences in package relationships. So in Debian we have like recommend, suggest, depends. And on the Mandriva, I know they have like the obsoletes, which I think is shared by most RPM implementation. And these are different things from distro to distro. Then we have simple things like lexical conventions, like the name of packages on the Debian side and the RPM side can be different. For instance, in RPM, there is a set as a virtual package name /bin/bash. while in Debian you can't have a package which accepts hashes in its name. Then you have the notion of virtual packages, which changes quite a lot from distro to distro. And finally, the biggest, let's say, difference between the deb part of the word and the RPM part of the word is that RPM permits to have multiple versions of the same packages installed at the same time, while DPKG does not. So for instance, the management of kernels installed is very different. On a Debian machine, you have different package names. So you have Linux, image, and then the version of the kernel in the package name. While for RPM, you really have Linux, I don't know if it's called Linux image, but anyhow, Linux image package name, and then you have different version of that package installed at the same time. So with CUDF, we actually drafted a format in which all these kind of differences are abstracted over. So let's have a brief overview of how this format look like. So it is in Unix philosophy, so it is a plain text file, no binary format, no XML, nothing like that. It's a very simple plain text file format. It is inspired by RFC 2822, which is actually the format of mailboxes. And technically, each CUDF file or document is a list of so-called stanzas. So the Debian people will recognize that this is very similar to our packages file, but it's not the same format. So you have stanzas which are separated by empty lines with comments. And each stanza is like actually a list of pairs where you have a key name and you have a value. And that value is typed. So in this very simple like hello world example, you have a package name, you have the name of the package key, you have this is the value of the package for this package, and so on. So values are typed. That means that this tree is not just a whole set of characters, is to be interpreted in a typed word. And the kind of types we support are very simple types with specific types for handling packages. So we have integers and positive integers, booleans, blah, blah. And we have package names, which are actually like a union of all possible package names for DPKGF on RPM. So this is a very liberal type where you can encode packages coming from both kind of package managers. So we can have package names like libcsys, libdb46, and even /bin/bash. This is the only way to have to support all kind of package names without having to do some form of escaping. Then we have package formulae, which are basically the usual type used for dependencies. So in package formula, it's like a list of dependencies which have to be satisfied all together, and each dependency is either a versioned package predicate, like this one, where you request that this package is installed at a specific version, or a disjunction. So here, for instance, we are requesting that postfix is installed at the version greater than 2, or that exim4 base is installed. So there is no specific version type. So I'll get to that in a minute. Versions are simple integers, but I expand on the subject in a bit. So the basic structure of a CUDF document is then a list of stanzas where you have a first stanza, which is optional, which is a preamble, where you declare some kind of metadata which can be used later on. And then the main part is actually a list of package stanza, one for each package known to the package manager, and finally one stanza which encodes the user request. Okay, so this is the usual structure, and here you just see what start each stanza. So you have a preamble which starts with preamble, package with package, and the final request with request. So package stanzas, which is of course the most interesting stanza we need to know something more about, usually contains these properties. Not all of them are mandatory. The only one mandatory actually is the package name and the package version. So the package version is an integer, and then you have all possible relationships with other packages, which are simply depends, conflicts, or provides. And depends and conflicts have the obvious meaning, and provides account for both DPKG, virtual packages, and RPM features. I think they're called in the RPM. So here you just say that your package provides like a that's again in the version, and okay, I jump to that because it's a very interesting subject. Okay, so the first remark on packages is that versions are just positive integers. Okay, so this might seem a bit strong as a choice, but it's really the only way to abstract over the specific details of version in different distribution. So the idea is that given a specific machine where you have a package manager running and some version of all packages, you can sort all versions of any package, and you obtain a total order among versions, and then you assign integers which represent the same order. Okay, so if my Debian machine, I can have a package with a epoch, and that makes that version sort some way in all possible versions of that package. I just assign an integer which respects that order. Yes, indeed. It is. So basically the idea that you represent that version with a different but simpler type, in this case which is the integer, which preserves the same property of your original version. Okay? So you might see when you say, I'm releasing 1.0-1, and then you have to put this integer 1, and then when I put the next package, the integer is bounced again. Indeed, indeed. No, you don't need to set it by yourself. So ideally, given a status of your machine, you can compute the representation. We just use integers automatically by some tool, which actually we already have. So doesn't that create a problem when you want to compare these CUDF files across different machines to verify that the behaviors, like you end up with a version of one package on another machine that is one, and the exact same distribution version that is number 2 on another machine, because the CUDF files can generate at different time. Yeah, so actually this is if I can restate your question, is if there is like a canonical version of a CUDF document. The answer is no, but I mean that's on purpose because it's not meant to compare different situations on different machines according to specific things like versions. It's just meant to reproduce the problem that your package manager will face once it tries to satisfy your request. So if you want to add some more information to remember the original version, you can do that with extra properties. And that's, I'll come to that in a bit. So the only other important thing about package stanza is that how do you distinguish what is the package universe, that is all known packages, and what is the package status, which is installed package. You have a very simple Boolean property called installed. All installed packages have true in that property, and all other have false, which is also the default value. So all packages which do not state whether they're installed or not are not installed. So we have seen this already. Versions are positive integers. So to encode a specific situation, you need to map versions to integers. And the other important things are that provides account for both features and virtual packages, and they are versioned. This is something which is uncommon in the Debian, like let's say in the Debian semantics, because in Debian you just have provides which are without versions, while in the RPM you have version provides. So you can write stuff like this. And if you don't do that, you are simply providing all possible versions of the virtual package called HTTPD. To account for RPM-like machine, RPM-based machine, where you can install different versions of the same package, we don't have implicit conflicts between different versions of the same package, which is the case in Debian. So in Debian, you don't need to declare that you are in conflict with a different version of yourself because it's implicit. In RPM, in a Red Hat-like machine, it is not. So if you want to encode the Debian semantics, you can do something like this. So you declare the package bash at version 5 conflicts with bash. Given that conflict on yourself are ignored, this basically means that you can install only one version of bash at a time. Okay? And the same kind of, let's say, trick is used for self-conflicts on virtual packages, which are used in Debian-like machine to have some kind of mutual exclusion between different implementation of the same virtual package. The common example is like a mail transport agent, which usually means the package providing users being send mail on your machine. So you have different packages offering the feature mail transport agent, like Postfix and Exim, and all of them both provides a specific name and conflict with that specific name. That means that you can install only one of these packages at a time. So in some case, like in the case Fabio reported, you might want to encode some extra properties for your package. For instance, if you want to go back easily from the solution found by a CUDF-based solver to something that can be passed to DPKG to install the specific packages, you need to encode the original version in your initial distribution. And you can declare to that end a specific new property, which is an extra property, which you declare in the preamble, and then you can use in your packages. For instance, this is just some example. You might want to specify the download size of a package, the installer size, who is the maintainer, whether it has some security fix. Just example, you can add whatever properties you want, as long as you declare it in the preamble. What about the request? So the request, at the very minimum, it's this just means that here it starts the request stanza, and then you specify which package you want to install, or remove, and upgrade. And what is the meaning of this kind of properties? So install, say which packages you want to be installed after a specific run of the dependency solver. And all what you write there, it's a version. So you can do stuff like, please install a version of bash which is greater than 3. And that request will be satisfied by whatever installation in which at least one version of bash greater than 3 is installed. That's similar for a remove, where you can request which package should not be there at the end of the installation. And with upgrades, where you additionally specify that all packages mentioned in the upgrade line should end up with a single version installed. So this is kind of interesting because in most RPM installation, you can request an upgrade of a package which is installed in multiple versions, but the semantics changes a lot from implementation to implementation. So the only way we found thus far to have a reasonable semantics is to request that upgrade end up with a single version of a package installed. So this is just a full example of how a CUDF document will look like. And several packages, blah, blah, and can be a lot. I mean, on my machine, I probably have like 3,000 packages. I can encode all of them in CUDF. And at the end, I have the request which has been posed by the user. So some technical detail before leaving room to questions. So we have a specific detailed specification of CUDF, which is available at the distro URL. And what is interesting is that the specification offers a really detailed semantics of the format, which can be interesting for the people interested in formal details, but it's also useful to check if an implementation is correct or not. So right now it's really difficult to detect whether a package manager is doing it right or wrong in satisfying a user request, because the semantic of the request is not really detailed. Well, in this case, you have a really detailed semantics, and you can check if the implementation is doing the right thing or not. We also have a specification of a related format, which is called DUDF, which basically grasps the same information of CUDF, but preserving all the distribution-specific information. That's interesting for like companies or for developers of package manager which want to capture all details, like in case of bug report. You want to report a bug against like IPT or RPM. You need to like embed all information in a single document and send it to your distribution editor to be able to reproduce what happened. So this format can be a solution for that. And there is also some documentation like a CUDF primer, which is really easy to read through to have an idea of how to implement this format. What is not yet implemented in CUDF, but it is needed in the real world, is like support for multi-arc, which is coming in more or less all distribution anytime soon. But we have a solution for that, and it's planned in a future release of the specification. So we have an implementation of this format, which is called libcudf, which is a kind of a reference implementation of the specification, and there's like support for parsing documents, support for checking whether a solution proposed by a package manager fulfills a user request according to the semantic of the document. And the library is implemented in OCaml, but there are C bindings, so you don't have to use OCaml if you are not willing to. It is LGPL and is, of course, available for download. And we have already both Debian and RPM packages. I do not guarantee on the quality of RPM packages because I've built them on my Debian machine, but they should be mostly OK. We have a command line tool, which can be used to check what's going on with the specific documents. So this is just some examples. So in this case, I just offer a document which represents the installation of all packages on my machine. So there is no specific request. But the tool checks basically whether all dependencies on your machine are satisfied and whether all the conflicts are not installed, meaning that you don't have two packages in conflict installed at the same time. And you can do other things like checking whether a specific document satisfies a user request or not. So nothing too fancy here. What is the status of the deployment of this kind of technology? So in Debian, we started a discussion with on the DAT mailing list, which is the mailing list where all package manager developers discuss. So they are pretty much all package manager developers are interested in this kind of stuff because they really want to factorize out the logic of solving in a separate, at least in a separate library. And this kind of technology helps to try experimenting with external solvers. So there is now support in CUDF, which is a new package manager, which has been starting to be used in the last month. And it is forthcoming in APT2, which is kind of a refactoring of APT by Julian Andreas Claude. And the main maintainer of APT right now, which is Michael Vogt, has been declared very interesting in trying out this kind of technology in APT itself. Elsewhere, so in URPMI, which is the package manager for Mandriva, and I'm not sure if also on some other distro, but anyhow, it has support for dumping the status of a user request in CUDF support. And it is forthcoming in RPM5, so it is the RPM fork maintained by Jeff Johnson. Also, some other distributions are using this kind of technology to collect reports from their users, like Kaiksamashika is doing that, and Mandriva itself. So we start to have a collection of this kind of documents. And of course, your favorite package manager can be the next one. So if you're interested in trying to use this kind of technology, you can talk to me and we can try to support you in adding support for it. Finally, the last interesting part about CUDF which is going on is that one part of the Mancusi project will be running a solver competition. What does it mean? It means that we will be collecting upgrade problems, let's call them, from users. So basically in the style of Debian Popcorn. So you have a machine, you can install a tool, and each time you try to do some change to your package status, you will have a dump of what you're trying to do in CUDF format, and then you can send it upstream to be collected. And then we will take all this corpus of upgrade problem encoded in CUDF, pass them to scientists interested in trying their own solvers on this kind of problems, and we will see if we find the dependency solver which is apt to our needs. The competition will be run at a workshop this summer, and we have some preliminary test results already. I forgot to add the number. So we have about 10 participants in this first run. XX is what I to do at the specific number of participants. I think it was 10, Roberto. So 7 teams working on solver, and some of them provided more than one solver. And for the moment, we tried 2 different policies. So we tried our trendy policies, which represent the kind of user which always want the latest version of all available packages to try out new features. He doesn't care about removing all kind of stuff or breaking things. So this is the policy which is called trendy. And we had a paranoid policy, which is rather the kind of very sysadmin, very paranoid about what's going on in the system, which want to upgrade the minimum number of packages and doesn't want to change everything at each upgrade run. And interestingly, we had initially some very good results from the solver, which is implemented in the Eclipse P2 platform to manage all the plugins of the Eclipse platform. And apparently it's having a very good result also in our upgrade problems like from Debian and Red Hat-based machines. So that's it. We have 10 minutes for questions. And if you don't have any specific question, we are also interested in have suggestions of specific policies. So have you ever had some kind of policy you wanted your package manager to implement? And if you want to suggest it to us, it would be interesting to see if we can encode it properly and try to find a solver which is good for that policy of yours. Thanks. Wait a second. Do we have a mic?
Thank you. Can you please go back to the previous slide?
Yep.
Okay, so you state there that you like to collect a corpus of real-life upgrade scenarios. I guess many people in this room are sysadmins managing production systems. And in fact, from time to time, perhaps quite regularly, we come across difficult upgrade scenarios, and we have to do all sorts of trickery to finally get a system that is actually correct. How can we help to provide you this feedback about certain status of systems? And I guess you'd like to know what is the current set of packages, what is the command that actually will trigger to do an upgrade, and what are the events we actually notice. Is there some kind of script that we can use to provide this feedback to you in an organized way?
So thanks. This is a very interesting question. So the first step is that you will need to have, in principle, a package manager which already supports this kind of format. So the step 0 is like checking whether your package manager is able to describe your operation scenario in this kind of format, because you're trying to push the technology first on the package manager. And then we will provide packages which you can install on the fly to just dump, and each time you made an upgrade, save the state and submit them to us. Right now, I don't have yet the specific tools to suggest you, but I'm interested to know which kind of package manager are you using to check if it is supported or not.
Wait a second.
All right, that? Okay. So right now, it is not yet integrated in that specific package manager, but we have libraries which can use to provide a self-contained tool which collect the situation and save a dump in this format. So maybe we can take this offline and provide a tool, and maybe we can advertise it to other interested people as well, because it's really something we are looking for.
More a comment than a question here. I mean, I am part of the people that has different difficult upgrade problem. Okay, so the first thing I wanted was to have a simple script to be able to upgrade, to upload, sorry, a report to the repository. And for Debian, there is one. Okay,
for Debian, yes.
Mention it. Did you have
yeah.
CUDF?
So for Debian, we have it. It's called DUDF Save, and I think it's available on the software page of Mancusi, or it will be soon. But for Red Hat, we don't have it yet. So the case,
you're in Red Hat.
His case, it was a Red Hat package manager. But we have the library which is able to pass all the metadata of the RPM database and save it in this format. So it's just a matter of wrapping it in a single tool and advertise it. So really, we can exchange emails, and I'm happy to drive you to have a working tool to offer also to other people. Yes?
I have one example of an advanced upgrade scenario or policy that you are working for that will be useful for sysadmin. It will be something as meets the trend of paranoid scenario depending on the category of package. Just for
so that's interesting because
precise example is install all available new version of package for everything already installed, unless this new version comes from media tagged as backport or unstable or unsupported, unless this update already applies to already backported package.
Okay, this is a very specific one, but thanks. So I'll take a note afterwards, so we take it. Anything else? So I'm not sure at which level you're posing the question, because if you're thinking about compiled stuff during post-inst, that's the point, or just...
No, if you want to reduce the minimal installation size, then you don't need to do that in the package management. It's something you can do post. Like some I think, apt as an hook for that, in which you can automatically purge all the user shared doc because you don't need them on an embedded system, or similar like that. You don't really need a policy to do that. It's more post-processing of the package.
So let me make a bit more clear what is this about. So what you're telling is that in some cases you know that in Debian packages there is some documentation you can avoid on embedded systems, so you have hooks to remove them. What I'm talking about here is different. So when I ask to install a specific package, I can have a dependency on something which is satisfied by different packages. So I made a choice. Like I have a dependency on a mail transport agent, and I choose either postfix or exim, okay? And this choice can be deep in the tree of dependencies. So you have a lot of different choices, possible way to satisfy user requests, and each of these choices has a different installed size. So maybe postfix package is smaller than exim package, so if you choose postfix, you will end up with less disk used. So this kind of policy belongs to the package manager because it's the package manager which is making this kind of choice. So what your proposal is a kind of a different level, is more than a hook, a hack which knows some specificities of the Debian package and knows where to remove documentation.
Statistically, how much can you save by choosing one package towards another? Have you done some statistics before implementing a full policy? Because otherwise, if you have a gain of 10 kilobytes after processing 10,000 packages, it's pointless.
No, that's a good point. On this specific policy, I don't have any data to share yet, in fact. But actually, even in that case, it's hard to compute the data without having the real-life request on which to compute the data. So once we have a corpus of real-life user requests, we can do on that a computation of all possible installations and see what is the difference between the installation which installs most packages and the installation which installs the least number of packages. So no, I don't have specific data to offer on this.
Do you plan to support multiple repositories or repository sources?
Yes, actually that is already supported because so the script which will collect the package manager information and save it, let's say in CUDF format, knows how the specific package manager works. So in the APT case, with the script mentioned by Roberto, we already consider all the repositories.
Okay, and so I could prioritize them also?
Yes, you can. So if you're thinking like at pinning, that can be encoded as well.
Okay, thank you.
You're welcome.
Zach, sorry, several users asked to comment on this question.
I cannot comment on that.
Maybe just a last comment on this. If you want the result of on the solvers, just go to the weblog of the Mancusi project. You will see a pointer to the current running competition of the solvers. So actually, Eclipse P2 is no longer the best solution.
It's live.
I mean, people are working to improve this. And sorry to say this, I do not believe we will end up having one solver that is best for all. This is the whole point of having this kind of common intermediate format. Depending on who you are, the policies you are going to use, probably the solver which is best for you will not be the same. What is really important to have a common format so you will be able to choose and plug in what is best suited for your needs or try different ones. And not hardwire specific ad hoc solving strategies in a particular package manager as it is the case today.
Anything else? So thank you.